Okay. So in the last video, I told you how to take the original board for roulette and how to uh, modify some bets so that you could get some bets to work out to be independent of one another. Now, in today's lesson, we are going to modify some bets again, although what's really significant about this lesson is now I've modified the board. And hopefully you can see that. You can see that I took out 0 and double 0. Those are no longer options. So our probabilities here are going to be out of 36 instead of 38. And we're going to see if we can work out to get some bets to be independent. Okay. So the first two bets that we're going to do are the 1 through 18 bet and the split 18-21 bet. Now these are, both bets that you can do in roulette. If you do them on the original roulette board, they won't be independent though. But now that I've made up a new board, these bets are going to be independent. We'll kind of see why that is. So first, let's take a look at the 1 through 18 bet. So I'm just betting on these 18 numbers, 1 through 18. So this is going to be 18 out of 36 for a probability, or 1/2. And then we'll look at bet B. So that's the split bet. So I'm betting on 18 and 21. So that's 2 numbers out of 36. 2 out of 36 will equal 1 out of 18. Next, let's look for our intersection. So I've drawn both bets on here. Where's the overlap? Well, it's on this one number, 18. So our probability is going to be 1 out of, well, this is the probability of bet A given bet B. So how many ways were there to win bet B? Well, there were 2 ways to win that bet. So this probability is 1/2. Now let's do it the other way. Let's do the probability of winning bet B given that we win bet A. Well, again, there's going to be 1 way to win both bets. That's our intersection, so that's going to be our numerator. And our denominator is going to be the number of ways to win bet A, which we already said was 18. So this will be 1 out of 18. And then what we should notice is the probability of A is equal to the probability of A given B. That means these bets are independent. We could have also compared the probability of winning bet B to the probability of winning bet B given that we won bet A. And when we do that, we see that both of those probabilities are 1 out of 18. So again, these bets are independent. Okay. So then, why did this work? Well, again, sort of the key here, and I'm not going to actually zoom out to show this, but if we take this value, 2, and we multiply it by this value, 18, that equals 36, which was how many numbers are on our board. So if we take 2 times 18 times 18, that equals 36. Now, again, just because those 2 numbers multiply to equal the total number of numbers on your board doesn't necessarily mean that your bets will be independent. It's necessary but not sufficient. You also have to get the overlap right. So, when you're doing this for your project, if you get, 2 bets where when you multiply the numerators, it equals the denominator for those 2 bets, that's a good thing, but they might not necessarily be independent. You might have to play around with how the bets are overlapped. And if you're confused by what I mean by that, watch the first video again one more time, and that will show you how to, the process for doing that. Okay, so now we're going to do a column and a street bet. Again, these are bets that are in the original game of roulette. So our column bet is we're betting on this column, 1 through 34. That's 12 numbers. And so 12 out of 36 reduces to 1/3. Our street bet, we're betting on 3 numbers, so 1, 2, and 3. And so that's going to be 3 out of 36, which is 1/12. 1/3. Okay, so now let's do the conditional probabilities. So what's the probability that we win bet A given that we win bet B? In order to do that, we have to look at the intersection. So where do these two bets overlap? Well, they overlap at one number, and that's at 1. Okay, so this is going to be 1 out of 3 because there's 3 ways to win bet B. If we do the other conditional probability, again, we need the intersection, so that intersection is one number. And then there's 12 ways to win bet A, so 1 out of 12. And then again, we can take a look and compare our probabilities to our conditional probabilities. So these values are the same, so that tells us that our bets are independent. We also could have looked at these two values because they're the same. These two bets are independent. Okay, let's look at one more set of bets. So we've done kind of 2 different bets that we have already seen on the original roulette board. Now let's make up some bets. So I'm going to make up a bet where you bet on 1 through 9. So that's kind of similar to like 1 through 18 or the first dozen, but now we're just betting on the first 9 numbers. Then the second bet is a bet on 4. So that's kind of similar to a corner bet, but you'll kind of see when I draw it out, it's not a corner bet because the 4 numbers don't make a square. They're actually just 4 numbers in a line. Okay, so here's my bet on 9 numbers. So that'll give me a 9 out of 36 probability of winning, or 1 out of 4. My bet on 4 numbers, again, so you can see this is not a corner bet because I'm betting on 4 numbers in a line, not 4 numbers in a square. So those 4 numbers are, give me a probability of 4 out of 36, which reduces to 1/9. And then if I look at my overlap, that's 1 number. So this will be 1 out of, and then there's 4 ways to win bet B, so this will be 1/4. And then for my other conditional probability, again, I need the intersection for my numerator, so there's 1 way to win both bets, so this will be 1 out of, and then there's 9 ways to win bet A. And so these are independent because the probability of winning bet A is equal to the probability of winning bet A given B. And the probability of winning bet B is equal to the probability of winning bet B given A. All right, and again, for all 3 of these bets, if we take the numerators of the single variable probabilities, 18 times 2 is 36, 12 times 3 is 36, 9 times 4 is 36. So again, this is a necessary but not sufficient condition to making sure that your bets are independent. If you remember from the last video, they either have to multiply up to equal the total number of numbers on your board, or they have to multiply to equal a multiple of the total number of numbers on your board. And so since these all multiply to equal 36, and 36 is the total number of numbers on the board, that makes it possible that these bets turn out to be independent. You just have to get the overlap right. And so in this case, the right amount of overlap for each of these bets was 1 number. Okay, so let me know if you have any questions. And hopefully this gets you set up for how to pick out some bets that are going to be independent for your project.